All right, guys, I'm back. Hopefully these examples I'm picking are making sense. I'd spent a lot of time looking for some examples that had some context to them. These curves that we're dealing with, this is really like Algebra 2, pre-calculus, calculus stuff even, in terms of just analyzing curves and seeing curves like this. But the simple things about it, I'm hoping you understand. So I talked about explaining what this fear function means relative to the ride. And if you understood what I said before about this being 2 pi, this being when you're back down on the ground, that would imply that back down on the ground there's no fear. I start with no fear, and I'm afraid of heights. This is relative to me, I guess. I start with no fear. Oh, everything's great. Oh, yeah. And we're looking around, and all of a sudden, I get somewhere, and I'm freaking out. I'm going crazy. If you look down from this maximum point, look down here, it's right around 3. It's just past 3. That right there is 3.14. That's pi. So when it says find and explain f of pi, find my fear when I'm at pi. In other words, find my fear when I'm halfway around this circle. I'm up here on the top. So you can do that. You could do this problem just with the graph, but I hope I threw this picture in here so there's some context to it. So it makes a little more sense maybe. F of pi is the f of the top of the ride. I am going crazy. And if you look across on the graph, well, my fear at the top is 1. So clearly, I'm afraid of heights. My fear depends on how high off the ground I am, or how far along the ride you are, or how much time. You could do this in terms of time as well, and that's why I said time or distance. And you could say this is 1 revolution of time. You could say this is 1 revolution of distance around the circle. And of course, this curve would, I don't know how many times I let you go around on the fair, but imagine my emotions on this fair. I just keep going and going and going. This curve would keep repeating itself. Probably by the third one, I'd probably be vomiting off the top. Um, Yet I still like roller coasters. I don't know. Way too much information. Sorry, guys. So back to the second answer here. We said this thing, f of pi would equal 1 because I'm at my maximum fear. 100% fear. And of course, I'm halfway around in the context of the problem. And the last one, f of 2 pi, think of this as 2 pi r, full circumference. I'm back down on the ground. Well, my fear down here, I'm back down to 0 fear. So the f of 2 pi is nothing, 0, no fear. Life is good again. So hopefully the context makes sense. If these examples, if I pick these correctly, hopefully that made sense before I talk through it. The last one on here is the rabbit problem, or the rabbit population, whatever you want to think of it here. So you should be able to do this on your own. Explain this function r of t. In other words, what do you think r stands for? What do you think t stands for? You can certainly look at the graph to answer that. Explain it in your own words. So hopefully you realize this is the number of rabbits. Depends on the time, and it's like the other one we did before, the time of the year. Think about when will the population of rabbits, when will there be the most rabbits, and when will there be the fewest rabbits? And you might even understand, what 0 would be here. Of course, you see it's in months. In other words, 0 months is January 1st. 2 would be, I'd say, the start of, if this is 1 month, that's the end of January, end of February, end of March. Right in here is where the population dips down to nothing. And maybe that makes sense. Why is the population falling here? Well, the coyotes are eating for winter. It's cold outside. These bunnies are freezing. I don't know. And then springtime happens, and life is good if you're a bunny, and there's lots of them, lots of them, lots of them. And again, we hit this curve back down again here. So this population is just depending. The rabbit population depends on the season of the year. It drops during some parts and it rises during others. So you should be able to do this by now, I hope. Find r of 2. In other words, find the rabbit population when t is 2, when the time is 2. And it's just an estimation. So you look at your curve, you go straight up, you use a ruler, you can get this a little more accurate. You'll notice these dots correspond to different times of the year. So we go up to 2, work your way across. Boy, it's pretty close to 600. Oh, and there's some more stuff you could have written for that last one. Maybe a little less than 600, maybe 590, I don't know, 550. Find r of t, or estimate, the r of 8, the rabbit population when we input a value of 8, x value of 8, so we go up to 8. Same thing, go up to the top here. We're getting pretty high in that situation. I think it's around 1400. I work my way across from here. I think I hit that dot pretty close. And then, oops, my range, again, the range is the y values. So it's literally the range of the y values. What's the highest y value you've got? What's the lowest y value you've got? So the lowest you go, it just came up here a second ago, is down here. And the highest it goes is somewhere up here. So you're basically looking here across the graph to find a number. It looks like it's above 1400. And you're working your way across from here, which would be somewhere above 400, maybe around 500, as I just had up on the screen a minute ago. And I put the equal to sign here because it's including 500. And then if you work your way across from that top point, you get somewhere around 1500. And I used R. You could also use the value Y if you want. It would make sense if you put a Y right there. Y values between 500 and 1500. And the last question on there, find the times. This is another, the question's reverse on here. Find times, plural, when R of t equals 1,000. So you could just go to 1,000 and work your way across. So obviously there's one of them. There's another one, and you might even find a third one somewhere over here. So I think the obvious ones would be time is 0. Time is 6, approximately. And of course the last one, if you think of this being a cycle, it's going to be at 0 months, at 6 months, and then again, of course, at 12 months. Now, 12 months and 0 months are kind of the same thing, but in terms of one cycle here, hopefully that makes sense. The population's back to what it was in the beginning, stable rabbit population. So hopefully you guys have an idea of how to do different things with functions. You can do it with an equation when it's given. You can do some things with it when your graph is given, and you can interpret. This is just about notation. We're going to do a little more with this again Tuesday, so don't be nervous. There's a homework assignment for you to start working on. Hopefully this made sense. Hopefully my examples I picked had some context and made some sense for you. So work on that homework, get it done in class, and life is good. I'll be here tomorrow morning, I hope. See you again. Adios.